object in our yesterday's class, right? Class and objects. Now, good that you have used even class and objects and making use of static methods, and also making it different class sectioning. Cool then. So today we'll actually move ahead and actually see more things what we can write in a class whenever we create an object. Right? So here we have a concept called constructors. Now, what is a constructor? So, constructor is nothing but a normal method whose name is same as class name, right? And this is a method which will get triggered the moment you create any object. Now, which means you don't have to call this method exclusively. The moment you create an object of class, this method will be called automatically. That is the constructor. So let's see practically how it is. Now here you can see that I have a class. Let me create a separate class. So that let me create a class here. Right. Let me show you constructor in a different way using my different program. And let me create one more class. Let me call it as trigger class. And I want my static void main in this here. So here let me write static void. And this is my class. Now here, this is a simple class. So whenever you create an object, I said whenever you create an object, so I'll take calc obj is equal to new calc. That which means I'm actually creating an object of class. Right? Now here, if you don't have anything in class, right, even then you can create an object. But internally, if you don't have any method or anything, right? Okay. So here, if you don't actually call any method or any variable to declare or anything, even if you have methods or variables, anything over here, right? Whenever you create an object, the compiler will actually create a default constructor here. Now let's see what is the actual format of constructor, or how do we define constructor. We will be using name same as method I said, which is the name of method again will be same as class, and will give some access modifier and then the expression. Now your constructor have got few very important things to follow. First, its name should be same as class name. Second, no return type. This is important. It shouldn't have any return type as such. You can see if I try to define some return type, right, then this is not a constructor, and it will say you can't use, right, or even if I return, let's say, right. Now what happens is, this is not a constructor. You can't use this as a constructor. This is a normal method which is like some other methods, right? So that's the reason why you can't use this as a constructor, because you have return type. So you shouldn't have any return type. So this is called as your default constructor you have. Now you can see here, let me write something here, console.writeLine. Let's say this is calc constructor. Right? So I'm just creating this in my trigger class. I don't want to call any method or anything. That's just the object. You can see I just created an object and that's it. I'm not doing anything. And this object, and in this class I have a trigger constructor, right, which will be triggered as soon as I said we create an object. Now let me run this program. You can see this is a calculating constructor got triggered, right? What does it mean is whenever we have we create an object, it immediately will go to this constructor, do operations whatever you have written, and then initialize your object. That's what happens. This is called as your constructor, and your default constructor will be your constructor without any parameters. If you don't have any parameters or arguments to your method, constructor method, then that is your default constructor. Now, if you don't define any constructor, let's say I don't have this constructor. Now it doesn't mean that this program will not run. It will run. See here, it will run. But the only thing is, the compiler will create a default constructor for you. Default constructor again. Keep in mind, default constructor is nothing but a constructor whose method name is same as a class name with no arguments in it. Is your default constructor, and this will be created by your compiler. But to create any constructor, then your compiler will not create any other constructor for you. Right? So that's how it works. Now, why do we use constructors? Well, normally constructors are used to initialize some values, or whenever you create an object, if you want to do some task as soon as you create object, right? Then for those we use constructors. Let's say what I'm going to use is, let's say I have two variables int a and int b. I'm going to take simple variables. Now here, as I said, I have a constructor. Right now, how can I assign these two? Right? In Calc, what I'll do, I'll just do a as 90 and b as 8. So these are two numbers. Let's say I have some methods called, let me take it as sum, right? And what I'll do, I'll just do something called console.writeLine. So here I'm going to take this. Fine. So using familiar thing, whatever we guys have done, I'm just trying to explain the constructor. But here you can see what I did. I just created an object and I just call a simple method called sum. That's it. I'm not passing any values. I'm not doing anything. Right? Which means it will take my values over here by creating an object itself, and then I'm actually doing this. Let me run this program. You can see as soon as I create an object, these things will be assigned, and as soon as I call some method, right, I'm getting the sum. So this is something where I have the constructor. Now what if I have to pass values? Now always don't think that I can actually ask here that every project may not be a console project, right? Where you want to you have a console.read line where you can actually get input and all, right? No. Sometimes you have to initialize these values through, let's say, your class here itself. Now there is a way that you can actually make it public, let's say, right? Obviously, what I can do, I can make it public, and here after creating object, I have to create obj.I or a is equal to 10, right? And obj.b is equal to 9, and I can call sum, right? So when I run this, right, you can see I'll get 100. I'm not saying that you can't assign, but this is something which, in maintenance purpose, right? Let's say you are actually increasing some numbers or anything, then what happens here? Then this may not be a feasible solution to provide to client. Every time client have to change different situations. I mean, in different ways he have to change his program. Now, in order to get rid of this, we have something called, you can write any number of constructors you want in a class. Now what does it mean by any number of constructors? Which means I can write Calc program again. How? Let me show you. There's a public. But yes, for all constructors, basic rule is your name of constructor should be same and there is no return type. Your basic principle of constructor should be same. But how I can write is, I can't follow the same signature for every constructor. each and every constructor should have different signatures. Now what is signature? Signature is nothing but your arguments mainly. Let's say I'm taking int I is my constructor. Now this is one more constructor which I have. This is a constructor and I have written one more constructor. Now you can see the name is same but the signature is different. Same way I can actually write any number of constructors. Like let's say int I comma int, right? Which means signatures are different. But I can't write same constructor which have got same type of signature. You can see it accepts int O, which is it is trying to fetch one integer value. Let me build this program. So when I build this, you can see there is an error. It says already there is an already member called calc which is accepting one parameter of same parameters. Now you can see that this is not allowed. Why? Because same method with same type of arguments, matching arguments is not allowed. At least you should have one thing different. Yes, number of arguments can be same, but at least you should have different type of. Now here you can see that yes, this is allowed. Right. Now this is a concept where if one method, again a constructor is nothing but a normal method where you're actually following some instruction to make it constructor. And you can see that I am able to write a single method in different ways. Right? Here I have a calc with no arguments, I have calc with multiple arguments and calc with some other methods. So if you write a method in different forms, right, then that is called as a method overload. So this concept of writing a method in different forms where your signature is changing is nothing but your method overloading. Right? Now what is the use of this, but how can I call this constructor? We know that whenever you are creating an object, you have to, your constructor will be triggered. But if I am writing these many constructors, then what is the way that my constructor will be triggered is the question. Right? Now this will be called even from your object itself. How? Now you can see here, whenever I am creating my constructor, you can see there are three different ways. If you remember, we were saying you can have any number of overloaded methods. Now you can see I can create a calc object using a default constructor or a constructor which accepts one integer or a constructor which accepts two different integers. Right? This is how I work. Now you can see you don't need to do all these things. Why? Because in my, let's say here INN itself, I'm going to provide A is equal to I and let's say B is equal to I. What does it mean? Whatever values I'm passing on while creating my object, I am assigning them to my A and B. Best way. So here you can see that I am going to use third type of constructor where I have to provide two values. Let me just say 1000 and let's say 500. 500 is mine. Now you can see your object will be created in the same form and you can call your sum. Now this is a new way how you can actually create an object using different constructor. Now if you run this, you will see 1500. The value whatever you are passing on in the same. Now this is called as your constructor and that is your overloading of your constructors where you can write multiple constructors with different signatures. Now this is something how we use constructor, and based on your constructor, right, your object creation will be depending on. Now when we say your object will actually depend on the constructor you are calling, right, it means that let's say if I don't have, let's say I am creating a default constructor. Now this is how we create an object normally. I mean normally whatever we have seen till now, right? But let's say if I have only one constructor, let me just comment this. What does it mean? If you remember just a few minutes back I was saying if you create any custom constructor in your class, then the compiler will not create any other constructor. The default constructor or anything it will not create. What does it mean? Which means Your CalC have got only one type of constructor called CalC, which accepts or which demands two arguments of type int. Now you can see, go back here, right? I can see to see here it says does not contains a constructor that takes 0 arguments, which means default constructor is not there, which means it will force you to use. Now you can see how many type of constructors you have, right? You have only one type of constructor. See, you're not getting any more. You have one type of constructor where you have to give some input. Otherwise, it will not allow you to create object of that class. This is how you can actually maintain your, your creation of object type using your constructor. Right? So this is how we can actually create an object and we can call it. Now these are called as your constructors. Same way, you have one more thing called destructor. Now even before coming to destructor, we said method overloading, right? Now this method overloading is not only applicable for only constructor. You can actually do overloading for any method. So here you can see there is a sum, right? I can actually go ahead and write one more sum, but with some, let's say I'm gonna take some parameter. So this is allowed. I can use the same name. Normally, in general, you can't use two different variables with the same name. I can't use A and A again. Right? I can't have two variables with the same name. No, it's not allowed. Right? It says already definition is there. Same way, you can't have two methods with same name. See, if I write same method here, again it will give you, it says already defined. Right? So, but your method have got different methods. Only methods have got different things that you can actually overload them. Where what is happening is this method will take some parameters and this may take some. Now this is called as a method overload. Okay. Now talking about destructor, destructor is something which will be called whenever your program is being disposed. And how can we write a destructor? And destructor is again, you don't have to call destructor. I mean, there is nothing that you have to call, or that even if your object is getting disposed to be called. For destructor, yes, you will have to use the same name. It is same as constructor, but you will be using a tilde symbol. Now this is your destructor. Now here, let's say you want to dispose something like I or A is 0. You want to reinitialize everything. B is 0. And say console dot right. Which means whenever you are disposing, whenever you are creating object, the constructor will be called, and whenever your constructor object is being disposed, your destructor. Let me run this. You can see sum, so enter. Now you can see destructor call because I'm actually trying to come out of program, right? And I came out. Right. So this is how a constructor and destructor will be called. Now let's any questions till here? Fine. So if everything is fine in here, let's go back and see the next topic, which is strings. So after the strings, we will see access modifiers. Now, why do we have to learn strings separately and not other data types? Right. Now we have integer, we have a double and all, right? Now why not? They are a defined set of data types where whatever we have learned till now, right? It can be casting, right? Casting from one type to other type. It can be casting of string to back to integer or object to integer, right? I mean, there are few things which are, apart from that, you have more things which can actually do in strings. So we'll see what exactly are they. Now we know that strings are, collection of, array of characters which we have. But in theory it is, but practically watching that, it is not an actually an array. It is an object where you can actually save multiple type of characters. Right? It's an object. String is an object. An object can save anything as such. But to actually make it string, we normally give data in double quotes. So inside whatever you define, space and whatever number you give, right? Everything will actually be a string. Now here, basically we have to understand that because in real time we'll be using strings in very often we'll be using strings. So that's the reason why we have to understand how string model works, because it is very important to choose whether you have to go to string or any other types to do some string operations, right? So normally we say string is immutable. Now what is the immutable nature of a string? Let me show you that. So here, let me take. So here, let's say string. How do we assign string? We have string s is equal to, let's say, 5. This is one string. Normally, whenever you create a string and assign a value to it, right? So that value will actually be saved in heap. Heap is nothing but your temporary memory of your application. Right? So normally, let's say this is a heap memory. So whenever you click on, whenever you assign high to string, right? Now what it will do is, it will not directly assign the value high to s, how it does in some other data types. When you say int I is equal to 10, what will happen? So I will have its own memory space and 10 will be saved directly into this memory space. That's what happens. But here it is not the case. What it will do is, whenever you assign anything to string as an object type, your string s first will search whether this word is there in this pool or not. And if it is not there, it will create a new space, right? New string over here, and then it will find it. This is what happens. Now, when you assign, let's say you are taking one more string, string s1 is equal to, let's say I am giving same string again, same string with same casing and everything matching. Then what happens? Your s1 will actually search the complete heap, right? And then if it finds the same string over here, it will point to the same string. That's what happens. Same way, your S2, you're pointing to high, it will again point to C. Now this is what happens. Now it is not the case with other data types. We have I10, or let's say L is 10, right? Or M is 10 again, right? Now they will have their own memory locations to save, different, the same value in different locations. That is how normal data is here, but this is not. Now what happens if I say S is equal to, let's say I'm actually trying to replace this y, or giving a new value to s. Let's say I'm giving something called hello. Now what will s do? S will be disconnected from this high, and before assigning hello, it will search whether this word is there or not. And if it is not there, then it will create a new memory location for new role, right? And then it will break this connection and create a new connection to progress. But what happens to this word? I will always stay because some other variables are different. However, let's say slowly your S1 got allocated to some other value and it got disposed, and S2 also got disposed. Then what happens to this high again? Now this will be orphan now. Now there is no referencing to this high, so that's the reason why your garbage collector GC will clear this one. It will clear this value completely. That's how it works. Right? Now you can see that as we are not able to change complete data in memory of your string itself. That's the reason why your string is called as a immutable natures. Right? It's a immutable. Now let's think of whenever you do multiple operations, right? Let's say I want to add two different or concatenate two different strings. Then what happens? Which means, let's say I have a string s is equal to, I'll say hi. Yes. Right? It means that it's appending two different values. It means, let's say hi is s1 and hello is s2. We'll see how to concatenate strings, no worry about that. Which means these are two different strings, right? Which means you have hi in some location, hello in some location, right? And it will actually append those two, say hi, hello, and then it will be the same place. That's how it works. That's the reason why, as you are not able to override the memory, right? Your string is a immutable. So this is why our strings, if you go to the multiple huge string operations in this, right? That's the reason why your program will become a bit slow. So in order to get rid of this, yes, we have more types. Like you can create an object of string or a string builder or many other things. So we'll actually come to that string builder or other things later. But let's see how we can actually create a simple string and do some operations. So for today, let me show you simple creation of string and printing it. Let me create a new project for that, strings. So let me make it as a startup project. So here we can define string. This is a class value and s is equal to x. Now this is string. And you can print console. You can see it's a simple string we have created and we are reading it. Right. Now this is a simple string which we have. In this way we can create any number of strings and we can have multiple operations. So this operations part, let's check it out in the next class.